Okay, so it cut me off at the very end of that problem. So your answer should have been 86,956.52 newtons. So we're going to do another practice problem together. Okay, so again, we're going to be looking at this total mechanical energy initial plus work equals total mechanical energy final. Again, we have our kinetic energy initial plus potential energy initial plus our force times distance times cosine equals our kinetic energy final plus our potential energy final. And again, our potential energy formula is mass times gravity times height, and our kinetic energy is mass velocity squared over 2. So we're going to be looking at this whole formula. We need to break it down. So looking at the problem, it says a 2,000 kilogram car traveling with a speed of 15 meters per second skids to a stop. The car experiences a 10,000 Newton force of friction. Determine the stopping distance of the car. So we again are going to be looking at our total mechanical energy initial. So that is our kinetic energy initially plus our potential energy initially. So we need to use these formulas to find those two. So initially we're going to be looking at how fast this object is traveling, because that essentially is kinetic energy. The mass of the car is 2,000, and the velocity at which it was traveling initially was 15 meters per second. And that's going to be squared over 2. So let's plug that into the calculator. So 225,000 joules of kinetic energy, and then potential energy. Again, whenever looking at potential energy, we need to look at if this object was elevated or not, and it's a car, it's traveling. It does not give us height, so potential energy is going to be 0 joules. So that's this section of the formula. Now we need to look at our work. So work is going to be force, which they give us as 10,000. We're looking for the distance, so we're going to keep that distance as just d. And then our cosine, we need to ask ourselves, is negative work being involved? And the answer is yes. It's causing the object to slow down. So negative work is going to be happening, so that's cosine 180, which again essentially turns this number, so your 10,000, into a negative number. So we're left with negative 10,000 times the distance. And again, that's the variable we're going to be solving for. And then going back to total mechanical energy final, we're going to be looking for that. So our kinetic energy at the end and our potential energy at the end. Kinetic energy, looking for kinetic energy, is the car moving, and it says it skids to a stop. So velocity is 0, so anything times 0 is going to be 0, so it does not have any kinetic energy. And again, it does not have any potential energy either, because it's not elevated. So at the end, the total mechanical energy is 0. It's not moving, it's not elevated, it has no potential or kinetic energy at this point. So now we're going to be adding our potential and kinetic energy initial together to get our total mechanical energy up here. So we have our work, and then adding these two together to get our total mechanical energy final. So we're going to be plugging these three numbers into that formula. So we're going to be left with our total mechanical energy initial, plus our work, which is negative 10,000 times D, and that's going to equal our total mechanical energy final, which is just that 0 joules. So, we again found our total mechanical energy initially, plus our work equals our total mechanical energy final. So now we just need to solve for this D. So we're going to subtract our energy to either side. That gets crossed out. Bring down the negative 10,000. And in order to get distance by itself, we're going to divide. And our distance is going to be so it took 22.5 meters for this car to stop, and that is your distance, and that is the second problem for the total mechanical energy. So hopefully these two practice problems have helped you understand the concept. Now I'm going to have you go to that worksheet I uploaded and try it yourself.